13. All right, so on your X13, you have a plug generally, and you have usually two wires. So these wires on the bottom are exclusively low voltage wires, and the wires on top, if you guys look at this plug, does everyone see that there's labels on these wires? See that? So
hold it up to the camera if you don't mind. Okay.
So can anybody tell me which two of these wires based off of this are the power wires for the motor? This is a 240 volt motor.
Let's say L.
L? That's one of them. All right, and what's the other one? Anybody know?
That'd be the G.
Nope, that's just a ground.
Maybe the black one then.
It's
Oh yeah, here we go.
black and yellow. So line is what that actually stands for, and neutral.
Okay.
All right. So on these X13 motors, the way they work is they have 240 volts present all the time. And they get a signal on the speed tap right here that tells it to turn on. So the two wires that you need for your speed tap, you have this brown wire here is labeled as C, which is common. So this is your low voltage common. This is your speed tap wire. This white wire here is just to tell the X13 the electric heat is on. So you actually don't need this on this specific unit. Some of these are going to be set up a little bit different. So to wire one of these up, we'll use a relay 1709 is generally what we use. And this is a 24 volt coil relay.
Actually, now, you might have missed one step there. He's putting a PSC motor in this in place of that X13.
Yeah, so we're where we left off last week.
Did you follow that?
Yes, sir.
He's not going back with the X13.
Hold that part. Hey, when you get done with that box, hand it to me. There, thank you. Okay.
So here's the relay here. So we have our low voltage poles here that control the actual coil, and then we have our high voltage side up here. So what we're going to do is, so normally you would just cut this plug off and strip your wires back, put spade connections on. But I've set this one up so that we can swap it back and forth. Okay, so we're just going to put our relay right here so that everyone can see it. Does anybody know which two wires we need to put on the low voltage side?
Your blue wire.
Blue, that's one of them. This is the speed tap.
Your brown wire.
Brown, yep, correct.
And high voltage would be black and yellow.
Yep, so high voltage side, we're going to take black and yellow, and we're going to plug both of these in on this side. So when this relay is not energized, you have power present between these two. When it is energized, there's power between this side and this side. So one thing that I like to do before I ever power a motor up is, once I have this set up, I will take my multimeter, I'll go to the thermostat, and I'll turn my fan to on. Mode off, fan to on. You should hear this relay click, and if you take your multimeter, go to VAC, and you test between these two poles, you should have 240 volts. If you do not have 240 volts, then you don't have something hooked up right. All right. So we got a capacitor here, so everyone knows that PSC motors require a capacitor, right?
Yes, sir.
So out of these wires, which wires do you think are for the capacitor?
Your brown and white, and your brown.
Yep.
Yeah, Colin, what's going on?
Killing that.
I'll take it.
I'm letting everyone know.
So we've got our capacitor hooked up. All right. Now, I'm just gonna separate this right here, so everyone can know this. So these are speed taps. This is neutral. You will always use this wire. This is always going to be one of your power poles. You will only use one of these. Never ever hook up two of these. If you do, it will fry the motor instantly.
And 90% of the time that wire will be white, but it won't be white 100%.
So if you look, when you take the motor out of the box, here's what I do. When I take the motor out of the box, I take a video of the labels on it. It'll tell you on those labels exactly how to hook it up, what size capacitor you need for which horsepower, everything. Which I guess I should have gone over that. So because I was using, I think this is a 1/2 horsepower, is what I was replacing. 1/2 horsepower. So according to the table on the motor, you use a 10 farad at 230 volts. You have to pay attention to that because it's going to change based off of what horsepower. So I'm going to hook up my neutral here. And so originally this was hooked up to speed tap 2. The blue wire was hooked up to speed tap 2. So on an X13, 1 is low speed, 2 is medium, 3 is high. So generally, I like to try to match what was in there before. Because sometimes, like say if I was to put high on there, the customer might complain that their unit's really loud all of a sudden, louder than they're used to. So I will take probably blue, which is medium high, and I'll use that speed instead of the highest. All right.
So I'm learning something here this morning. So on that X13 motor, that 1, 2, and 3 on that blue wire went to. If you want to speed up or slow down that wire, you can change it from 1, 2, or 3.
Yeah. So
Yeah.
If you want to speed up or slow down that motor.
Yeah, if you want to change the speed, you move the blue wire.
Okay, I never knew that for sure.
This wire here, like I said, you can eliminate this. You don't need this. When the electric heat strips come on, it's still going to energize this relay. So that's basically it right there. That's how you hook it up. And obviously, when you're doing this, normally I'm going to have these wires inside of this cabinet, and I'm going to mount my relay with a screw, and I'm going to use plumbing strap, and I'm going to mount my capacitor. I don't want to see any capacitors just sitting in here like this, because I do see that sometimes. Make sure you mount the capacitor.
I sometimes mount mine to the motor housing, but
As long as it's mounted, that's the most
As
important.
long as you don't have, if this is loose inside of there and it can come in contact with the transformer, or it can fall and hit the side of the unit, then it will fry the motor.
Oh yeah, and also some guys will not here, but come behind other companies. They'll leave it in the box, just sitting in there like he's talking about.
Yeah.
That is
Which
the
is better
most
than leaving it in the
redneck
oven.
thing you could ever do.
it's all right. I mean, it's some of those ream units where there's not any. Sometimes there's not any place to put it. Sometimes it's about the only thing you could maybe do is put it in the box.
And a good practice when you're changing a fan motor, period. Go when you get it set up. If you're not sure if it's rotating the right direction, go and feel the air vents. If you don't feel any air coming out, and you don't hear any air resistance coming out of this, then it's spinning backwards. And how you would remedy that is you have this plug here on these motors. You just unplug this and you turn it around.
Rotate it half a turn.
So I'm going to leave it the way it is because I think it's on the right rotation. That would be how you would do that. The rest of these wires here, you need to take over these.
Because they don't have power. Yeah.
I've seen before where somebody didn't tape them.
And tape
And
them
they were-
all individually, not together.
Yeah, tape them individually. These were floating around and they were coming into contact with this insulation here and they were burning it. So definitely make sure you tape off all your unused connections, including this one too. All right, anybody got any questions?